In this video, we're going to talk about how to solve systems of linear inequalities by graphing. So remember how we graphed linear inequalities? Each of the graphs has two parts. They have a boundary line, which is a solid or a dotted line, and a shaded region that includes all the points that are solutions to the inequality. So in a system of linear inequalities, you have more than one inequality. To solve these systems, you're going to graph each inequality individually using the boundary line and the shaded region. Then you're going to find the region where the shading overlaps, and that is the solution to the system. So in this example, you can see here where the red shading and green shading overlaps is where we find the solutions to the system. So an ordered pair is a solution to a system of inequalities if it makes both inequalities true. So for example, here you can see that 3, -1 is a solution to the system because it does fall within the overlapping region. So let's first determine whether the ordered pair -2, 4 is a solution to this system. Remember, -2, 4 gives us an x value and a y value. So what we're going to do is plug it into each inequality to see whether it makes the inequality true. So if I try the first inequality, I have -2 plus 4 times 4 is greater than or equal to 10. So that becomes -2 plus 4 times 4, which is 16, and that's greater than or equal to 10. So -2 plus 16 is 14, so 14 is greater than or equal to 10 is true. Now let's try 3x minus 2y. So we have 3 times -2 minus 2 times y, which is 4, is less than 12. 3 times -2 is -6, so we have -6 minus 8 is less than 12, which is -14 is less than 12, which is also true. So that means that -2, 4 is a solution. So remember the rules of graphing inequalities. For the boundary line, you're going to use a dotted line for a less than or a greater than sign, and a solid line for a less than or equal to or greater than or equal to sign. So for the shaded region, you're going to use a test point that's not on the line. For example, use 0, 0 to determine the shaded region. So we have to graph inequalities by hand. The testing version of Desmos in your TI calculator does not allow you to graph inequalities. So you can see in the star version of Desmos, it says that plotting inequalities is disabled. So let's solve the system of inequalities by graphing. So we want to first make sure that both inequalities are in y equals mx plus b form. So we have y is greater than or equal to 2x minus 1. So this is in mx plus b form because 2 is m and -1 is b. So remember, if I'm going to graph this, I'm going to go to -1, and then I'm going to count slope, which is m equals 2, which is 2 over 1. So I'm going to go up 2, and then I'm going to go right 1 to plot my second point. So once I have my 2 points, I'm going to use a solid line because I have a greater than or equal to sign. So I'm going to connect these 2 points using a solid line, and then I'm going to use a test point to figure out where to shade. So if I plug in 0, 0, which I can do because it's not on my line, I get 0 is greater than or equal to 2 times 0 minus 1. So that becomes 0 is greater than or equal to 0 minus 1, which is 0 is greater than or equal to -1. And so that is true because 0 is bigger than -1. So I'm going to shade towards 0, 0. So I'm going to only lightly shade because, remember, this is not my final solution. I want to actually graph both inequalities and see where it overlaps. So now what I'm going to do in green is I'm going to do y is less than x plus 1. So when I have y is less than x plus 1, remember this is also in mx plus b form. So here's m, here's b. Since there's no number in front of x, remember there's an implied 1 there. So I'm going to go to my graph. I'm going to plot b equals 1. And then my m, which equals 1, is my slope. So that's 1 over 1, which is up 1 and then right 1. So from 1, I'm going to go up 1, right 1, and put my second point. Since I have a less than sign, I'm going to use a dotted line. And so I use a dotted line to connect these points. And then now, once again, I need to figure out the shaded region. So I'm going to use 0, 0 because it's not on my line. So I have 0 is less than x plus 1, which gives me 0 is less than 0 plus 1. So I have 0 is less than 1, which is also true. So I'm going to shade towards 0, 0. So when I shade towards 0, 0, you can see there's an area where I have both purple shading and green shading. So that is this region right here. So this region right here, this triangular shaped region, is my overlapping area. And so that is where the solution to my system is. So that's why I'm going to shade this in more darkly, because that is the solution to my system of inequalities. So now let's try graphing the solution to this system of inequalities. So we have x plus y is less than or equal to 2, which is not already in slope-intercept form. So what I'm going to do is I'm going to get it into slope-intercept form by subtracting x from both sides. So when I subtract x from both sides, I end up with y is less than or equal to negative x plus 2. So now this is in slope-intercept form. I have m and I have b. Remember, m is the number in front of x. If there's no number there, that is an implied 1. So my b is 2, so I'm going to put my first point there. M equals negative 1, which is negative 1 over 1. So that means I go down 1 and then right 1. So I go down 1, right 1, and I put my next point. Since I have a less than or equal to, that is a solid line. So I'm going to connect the 2 points with a line. And then we need to find a test point. So I can use 0, 0 because it's not on my line. So when I plug that in, I get 0 plus 0 is less than or equal to 2, which gives me 0 is less than or equal to 2, which is true. So I'm going to shade towards 0, 0. So that is this side of my graph. So now I'm going to work with y is greater than or equal to 2/3 x minus 1. So I have y is greater than or equal to 2/3 x minus 1. This is in slope-intercept form. 2/3 is m, and minus 1 is b. So I'm going to go to negative 1 and put my first point there. I have m equals 2/3, which means that I go up 2, and then I go right 3. So I'm going to go up 2, 1, 2, and then right 1, 2, 3 to put my second point there. Since it is a greater than or equal to sign, I'm going to use a solid line. So I'm going to use a solid line to connect these 2 points. And then I can use 0, 0 as my test point since it's not included on my line. So I get 0, 0. I plug in for x and y. So I have 0 is greater than or equal to 2/3 times 0 minus 1. So I have 0 is greater than or equal to 0 minus 1. So I have 0 is greater than or equal to negative 1, which is true. So I'm going to shade towards 0, 0. So that would be this side of my graph. And now you can see there is a overlap in the shaded regions, right? The region where the shading overlaps is what I'm going to highlight here in blue. And I'm going to shade that in more darkly because that is where I can find the solutions to my system of inequalities. So now let's graph the solution to this system of inequalities. So we have y is greater than 2. So remember, this is one of those special lines. This is like that y equals 2 line. So remember, we have that mnemonic, hoi, that tells us that y equals is a horizontal line. So this is going to be a horizontal line through 2. And since it is a greater than sign, it is going to be a dotted line. So I'm going to put a dotted line through y equals 2. And then I'm going to use the test point 0, 0. Since there's only one variable in my inequality, it's 0 is greater than 2, which is false. So I'm going to shade away from 0, 0. So this is my shaded region for this graph. So now I'm going to try the other inequality. I'm going to do y is greater than 5x plus 1. And so this is in slope-intercept form. This is m and this is b. So I'm going to plot my first point at 1. And then I'm going to use my slope, which is m, which is 5 over 1, which is up 5, right 1. So when I go up 5, I go 1, 2, 3, 4, 5, and then right 1. It's since a greater than sign, I'm going to use a dotted line. So I'm going to connect these 2 points with a dotted line. And then I'm going to plug in 0, 0 as my test point. So we have 0 is greater than 5 times 0 plus 1. So we have 0 is greater than 1, which is false. So 0 is greater than is false, so I'm going to shade away from 0, 0. So when I shade, it's going to be this side. And now you can see the area where the shading overlaps is in this upper left-hand corner, which is this region right here. So this is the region that contains all the solutions to my system of inequalities, everything up in this corner. So remember, to solve a system of inequalities by graphing, you're going to first graph each inequality individually. Remember that each graph will have a boundary line and a shaded region. The area where the shaded regions overlap will be the solution to the system of inequalities.